It's 11:15, so I guess I need to start. All right. The talk is going to be not about dependency injection, rather library injection, but I thought that injection right now is really like buzzword for dependency. However, it's going to be like a hack talk, so and I'm going to talk something which is actually in production. So it's not like, you know, a project you're doing overnight. All right. Let's do this. Right. So who am I? I'm Przemek Jakubczyk. I work at Applause in Warsaw. I'm technical lead there for Android. Sounds good, but actually there's only 2 Android guys in the company, so it was quite easy to get it. Yeah, anyway. It's all branded with my company because it's, as I said, this is a production service. And first of all, what was the motivation of the scripts, of the hack we did in our work time? So first of all, Applause, my company, ships an SDK, which monitors app state, like Crashlytics stuff, but not only for crashes, like screen reporting, conditions, like Wi-Fi stuff, anything you want. And often our clients didn't want to mess with development process. So once the application is being packed, sent to the project manager, and saying them, okay, you need to integrate with our service. So the project manager needs to go back to developers, so us, okay, now you have to use this library because our business model requires it, right? And as a developer, always like, really, do I need to do it? I mean, they always like mess around. I mean, I don't know this library. It will crash for sure. So we discovered that actually it would be better to skip developers in this part. So actually the project or product owner, don't care what's the name of the company, can do it himself. Okay, or to configure it different way. All right, let's go here. So the hack is going to be about that we have a binary from the Google Play Store. We have our library, and we will produce a new APK, actually. So let's do a small recap about what's inside Android, how it's being built. So first of all, we have Java source code. This is all we know quite well. But of course, Android doesn't run on Java, but it also doesn't run on class. This is just the backend stuff, and we do just inherit from it. Well, officially, Android runs on DEX, so Dalvik executable, depending on if it's actually Dalvik or Art run at this moment, but doesn't matter. So, but basically, there are like 2 steps to achieve the binary code. When it comes to resources, it's also a little bit different than on backend systems because we have PNGs and XMLs, and actually they're also compiled to save some storage and to speed up XML's reading. But let's not talk about it a little bit too much. So first of all, we need to disassemble the APK. There are like many tools for that, but I'm concentrating on one. It's APK tool. And I'm going to tell you why. So first of all, APK tool gets the DEX compiled classes and the binary resources. So these are like 2 inputs. And what it produces Smiley files. So this is our new source code. This is like a new language, very similar for the bytecode. And we have PNG assets, so extracted, and other XML-based resources, also a manifest, but human readable. Everything is just plain text file, nothing binary. So we can easily, add some stuff and save and check what's there. So let's talk a little bit more about the APK tool, but in reverse. So because APK tool can do it both ways. This is not very popular tool. However, there are other disassembling tools for Android, but they cannot do both ways. So APK tool, once it decompiled stuff to formats it understands, it can do it the other way around, which is good. That's what we want. For example, do you know like Java decompiler? Maybe it's just DEX to jar. There are some tools. They won't work because they try to extract DEX executable code to jar. to classes, and Android doesn't run on classes because it's a different kind of virtual machine. It's not heap based, but it's registry based. So that's why you have to use different model. Okay, so let's first start with an example. So let's assume we have like a very simple application that it does only one thing and actually shows a toast. Nothing spectacular, I guess. And just a second, I lost my cursor. Oh, okay. So this is the decompiled version of the same class. I'm not gonna talk about discounts, invoked static, blah blah blah. This is not that important. But as you can see, actually, we don't have any r.string reference. This is like a address in the memory, not in the memory, rather in the resource table, and we're using the same value to display it. So, okay. So the trick I'm first going to show is that I'm going to add a new resource to decompiled application using the APK tool. So let's say it's no worries. And the thing is that I have to assign a new number for this resource. This stuff usually is done by Android compiler to assign a unique address for each resource, right? But in this case, I'm not using Android toolchain. I'm using something which is something in the middle. So I have to assign the address myself. A hint: it has to be continuously increasing. Okay, but we have this number, right? So in the code right now, when I'm using address number 2, and I would compile it again and run this binary, it will show the different toast. Nothing. I mean, right now it's just okay. This is how it works, right? All right. So let's do it again. So we have a binary, we have a library, and we have a snippet of code because putting a jar file or AR file into a binary, it doesn't mean that it will start just right away. You have to have like a starting point. And for the presentation reasons, I'm going to use my friend's app, Pola. This is not something that I created, some example application which will always work. This is like a real application I got from the Play Store. So the agenda actually for the presentations is look like this, and it has like 8 steps, actually 7. Some of them very easy, some of them a bit more complicated. All right, so. First step, decompile and unpack. So we have this Pola APK, and it just APK decompile Pola application. We have something like this. This is the output from APK tool. So here are the source code and the resources and other stuff which are bundled within the APK. And for the library, actually library Android archive is a simple zip, so we can easily just unzip it. And you see that we have the resources, some GNI stuff, whatever. This is always like that. And we have the classes jar. So this is still in the class format, nothing text. This was easy. Then let's merge resources. So first of all, you need to just copy the directory from one to another. It's still easy. But as I showed on the picture before, that we have to assign new addresses for newly added resources. We're not using Android compiler, so there's no one that would do it for us. So we have to do it by ourselves. So for example, if we have like a layout file, this is the last layout from this Pola application, and it has 2E address at the end. So I need to address my first library layout to 2F, and the same would go with the string, IDs, styles, any kind of resource you have. You have to just be aware that it's consistent. So, for example, the IDs using this scope, which is 7FOE, so this is for the IDs. For strings is 7F08, so they have like small boxes within the resource table. Okay, this is not complicated, but it's like time-consuming to write such Python script because you have to first check, which ID range layout uses, string, etc., etc. Okay, but that's not only for to change this public XML file. You have to also include the R Java, which is also generated by the Android toolchain. So you have to do basically the same thing, but the output is not XML, it's just this string, right? The same number, so this is like easy peasy while you got the previous logic. And this was strings. And you have to repeat it for any other resource, like IDs, layouts again. It's just time consuming. So about the resources, there's one digression. So normally when you have R Java, you have public static, int, and final. It means that it's a constant. So when a compiler checks, okay, this is a constant, actually I don't need to do like another jump in registries to get some kind of other resource, so I can skip 1 point. So this is like a good improvement. So compiler does it automatically. So it will, instead of having this reference, like I showed in the first slide, I will use just the number. There will be no like r.string dot something. But for the libraries, it's a bit different. I'm sorry. Oh, so this was the example I was talking about. But for libraries, it's different because the R class is not static final. Because the R class needs to be recompiled again in the final application to get other libraries to have like in the one common R class, so the application can access the resources from the libraries. So that's why it has to be like regenerated. But for the compilation reasons, when you compile a library, it's not final because it will change. And the output of it, that actually when you check the decompiled code, you will see that actually I'm referring to a field in our string class. So I don't need to run into the source code and check, change every address which my library was using. It's a very useful knowledge. For example, you cannot do like switch case on IDs in library because they are not final. This is the same story. Okay. This shouldn't be here. Sorry. So that's for the resources. Now we have the manifest. So the manifest is quite easy because basically you need to like merge two manifests. So if the main application is missing like Bluetooth permissions, we have to just add it. Any other activities. And why it's easy? Because Android manifest has a totally defined structure. So you open the documentation and you can totally say what can you expect in which HTML tag. So it's like another kind of Python script, read one XML file, read second XML file, merge them together. Okay. So step 4, merge the code base. So the code base is, as I said before, that's Android archive has classes, and this is not binary code for Android. So there's a tool within Android toolchain called DEX. It's DX to convert classes to DEX files. So this is you have already in your on your laptop, and you have to because we're using APK. APK doesn't understand classes. I mean, because we want to put something back in the chain, so we have to use Smiley compiler to generate Smiley files. So again, we have to from class to DEX to Smiley. And then at the end, just merge two directories you've produced. So first, the Smiley files from the application, and the second, the same structure, like all the Java packages have just cp-r. That's it. Okay, this is another step. And so this is the most tricky part about the whole hack. So how to find a place and inject our code into application, because at this moment we didn't mess around about the application code. Okay, we changed the R class but it's not a big deal. It's a well-defined structure. How does it look? And here it's a bit different because we have to inject some kind of snippet into the application. So yeah, so it's half access, and we have to find a reference to the library, and this was our business requirement to start our SDK as soon as possible. So for Android, as soon as possible, it means that's application on create. I know there's on attach base context method on application, but it's used for different reasons. As an Android developer, you have to know that if you do like a bootstrap or like starting your database or dependency injection, whatever, you have to do it like in application on create. This is like your first way to go, right? Okay, and okay. So now we have to locate where the application is starting. It is easy because Android manifest tells us very precise where to find this file. It's within application tag and Android name, which is easily refers to path on the file system. So no need to run like regex over the whole directory. Okay, and now we have to put the snippets running. So actually there are two methods. We have implemented method 1, then we found out that actually there's method 2, which is much simpler. But as it always, if it works, don't touch it, right? Okay, so the method 1 is about changing the onCreate method. And we have to paste our code before application's code. So somewhere in between super onCreate and the first call of the application's code. Somewhere in the middle. So let's see what Pola's application has in application.class. So this is it. There's no hate here, right, guys? So, I mean, we all know that we could put retrofit somewhere else, whatever, right? This is not the case. But it looks like a really onCreate method. We have like a bunch of stuff, passing if statements because we have like debug production stuff. We have some kind of configuration like for OK HTTP client. Okay, this looks very good when you read Java. This is, I fit it on one page. It's short. And next slides, I'm going to show it what's looked in Smiley, so in assembly code. Slide 1. This is the first part, and I only read like 4 lines. And I highlighted on red the registries which are using here. So if you know how the registry machine works, it usually reuses the registry once it's done, not to allocate more. So if you see like here, like P0, which is a parameter, V1, this is a variable. So those stuff will be like repeated a few times over the same snippet of code because the virtual machine tried to reuse the same registry. This is page 1, this is page 2, still a lot of code. We have again like V1, V0, V4, V5, some constants. This is the third page. This is the fourth page, still V1, V0. So you see, it's keep repeating. So it's not easily to track what actually this registry holds. And we got to the end in 5 pages. So I know Java code looks, ugly for people who write in other languages, but in assembly code looks totally bad. But this is assembly code. Assembly code is not meant to understand by people. It's meant to understand by machine. So usually we don't care what's inside. And what's about the method? So actually, this is our snippet we need to paste in the Smiley code. So the thing is that if we'd like to put it somewhere, at the early beginning, the problem is that in Java code would be very easy, but for the compiled stuff, we have to be very careful on registries, variables, fields, parameters, because we might mess up some stuff. It's very delicate. It took us, 1 week, to run it again to find a good algorithm. And actually, at the end, we found another hack, but this is like to talk about, while the beer in the evening. But what's it showing? It's showing that, modifying the assembly code, it's possible because it's a text file, so it's very easy even for a human to, read it and, let's change variable 1 to 2 or some constant numbers. But it's like, it's a very delicate process, and you have to have like a very good script which will enable all kind of edge scenarios you would imagine. And mind the fact that this is working on production, so we like injecting our code to guys like eBay or another big companies. They have like, in this on create like a, first chapter of the Bible. This is this long, so really like find a good place there in the middle. It's not that easy, but it's possible. It's just, matter of time, right? This is understandable, but it's just time consuming. But then we found another method. So the method 2 is much easier. So we can actually replace the application name to our library application. So instead of having like Polar application reference in the manifest, we can easily change it to ours, right? And it implies that we have to also change in Java code it would look like this, very easy. So it means that our application would be first, so we can, create like a ready-to-work snippet and then pass back the procedure to the Polar app. But how does it look in the Smiley code? It's even easier because this is the header of the class Polar application. So we have to change the super call. Easy. It's just a really simple regex. So find super empty space L, and what's in between the semicolon, replace it with ours. So we have one regex. And the second regex is actually because we have to change the super calls, because normally you don't see what's behind super. You don't care because you change the inheritance and it's done for you automatically by the compiler, but still we have like a binary code, so we have to take stuff by ourselves. So while invoking super, actually it means that you have to invoke this method from this application. Easier, right? I'm regretting myself that I found it so late. Okay, so this was the most tricky part about the hack. And there's a very important thing about signing, because the seal is broken because basically we added some new things to the working binary. So in very short words, the MD5 signature is different. So the Google Play Store will of course drop the binary because it's not the same. And so what does it imply to? That we have to use our own dummy certificate to install the application because the seal is broken, so we have to have another certificate to run it on the device. Device always requires some kind of the certificate, but it doesn't care what was the certificate. It's easier than on iOS because iOS has these profiles and it's really integrated with the system. Here is just key gen tool to make a new key ring. It's very easy. And we have to be aware that once we change the signature, some stuff won't work, like Google services. Because Google services checks, if this version of this application can talk with their like push notifications or maps or Firebase, I guess, maybe next talk they're gonna talk about it. So, but overall, I mean, the binary has changed. This is very important that you cannot just ship it to the world and, okay, this is the new eBay app. It won't work because you have to sign it. And who has the signature? The application owner, of course. So they don't want to share it. But for the testing reasons, I mean, for kind of, reporting stuff, it's quite fine. So as I say, this is just important. Just be aware and, yeah. There are some limitations. Some of them we solved, but some of them they're not easily solvable. What are they? So first of all is famous limit. And 60 it's like Bill Gates, like in 80s, sorry. Yeah, so the authors of Android thought that, yeah, 64 methods is going to be enough for any application you would imagine. They got wrong a bit. So there is like a solution Google introduced. It's called multidax. This is like a native script that can slice up your big DAX file into smaller pieces, and using some very interesting logic in class loaders, they are able to allocate more methods in the same virtual machine, and it's compatible up to Android 2.3, yeah, something. Yeah, anyway, but imagine the situation that I'd like to inject my library into eBay, but eBay already has 62,000 methods, but my library has like 4,000, so there's a glitch here, right? So we have like a small hack how to check whether the application is using multidax, and if it's using multidax, we have like another modification where to store our code. But if you're really like interested in how it works, I would need to show it on a laptop and with piece of paper, because it's not that easy and requires some knowledge about the class loaders, and this is kind of boring. But this is like a valid limitation. The other thing that this I was totally lazy, because do you know how to create like custom attributes for XML files? Most of you probably know that there's like generator. I mean, there's name dash, but sometimes it's dot, sometimes it's it's a bit more complicated. So we just decided just to skip. We don't use the custom attributes in our library. That's a valid thing to think about. And this is very interesting, actually. We didn't know at the beginning that there's going to be a problem for it. Do you know DexGuard? Not ProGuard. Do you know DexGuard? Some of you, like half? Let's be half. So DexGuard is a third-party tool. It can, a part of the optimization which ProGuards do. This DexGuard is a commercial version, and it's hiding and encrypting your strings. There's like lots of weird stuff. They're trying to make the reverse engineering more difficult. Not impossible. This is very valuable knowledge. And how they do it, they rewrote the Android resource compiler. And they also changing some parts of your binary, because they have access to your source code. So it's much easier to create, like there was a talk about code generation before. So if you have like Java classes, I mean Java files, it's very easy just to modify them, because it's like a very nice structure to change. And since they're using it, the thing is that Android's virtual machine accept the output of DexGuard. But if you decompile the output from DexGuard, and to compile it again with APK tool, it won't work, because APK tool is based on the official Android Google compiler resources. It's just genuine stuff. So while you're using the DexGuard, you're breaking the chain somewhere in the middle, because you're using a third-party tool, which doesn't allow to compile it back. The huge difference is like that you can normally in resources you have to use like small letters and dashes. It's not there are no dots like any other characters, but DexGuard accepts it. For example, it compiles it to the binary, so it's fine. Also interesting to know. And actually, this is it. I encourage you to play with APK tool and check what kind of modifications you can do on your own. And there's also a question part.